Kids, hey, we're gonna do more graphing stuff, except this time we're gonna talk about energy. We're gonna graph energy, and we're gonna talk about how you could make a graph. So we're eventually gonna have a graph over here that is going to be energy versus, we'll do distance, just for, for the heck of it. And we're going to need to graph things like UG. We're going to graph old kinetic energy, 1/2 mv squared. New kinetic energy, 1/2 I omega squared. We'll graph heat. We'll graph all kinds of stuff. It's going to be amazing. Just you wait. So here's our situation. So we got a little bit of a weird situation. We're going to have a ball that is going to roll without slipping going up a ramp. It's going to go off a ramp, and then it's going to turn into a projectile, and it's going to go to there, okay? And we want to show the energy for all the different pieces. All right, so, okay, remember, in physics, when we're struggling, we draw a picture, and you might be like, well, there's my picture. But the problem is, this picture is not complete, so let's make it complete. We're going to label some points. I'll call this my point A. Well, what's my next important point gonna be? Well, here. So let's draw our picture here. Well, what's happening there? Well, the ball is moving slower, and it's also gonna be rotating slower. Okay, so let's show that in our picture. Okay, how do we know that? Because we have a brain and we have common sense, and physics makes sense. When things roll up a hill, it slows down. Physics makes sense. Well, after it leaves, okay, when it gets to this point, so let's draw a picture at the top, okay? Hopefully we're good with this. Once it leaves, the only force acting is gravity. Gravity acts from the center. Gravity is not going to exert a torque. If gravity does not exert a torque, then the rotation is going to stay the same. So if I draw my picture here, I am rotating exactly the same speed as I was there. I'll call this my point B. This will be my point C. Okay, so I'm rotating the same speed, but I am moving a little bit slower. Am I moving? Yeah, because remember, right there, you're still moving. Okay, you're just moving a little bit slower. So I'm going to show that I'm moving this way slower than I was there. So, and then when I get to down here, right before it hits the ground, I'm still rotating at the same speed, but now I'm going to be moving even faster than I was here. Why? Because I sped up for more time, so I'm just going to show that, hey, I'm moving faster than I was there. Okay, how am I doing? Everybody, hopefully we're good? Good. Now, it kind of depends on, what this thing is. Maybe we'll say it's a solid disk. The reason I'm going to say it's a solid disk, then while it's rolling up the incline, I'm going to know that it's going to have 2 times as much like translational kinetic energy as rotational energy. And how do I know that? If you do your 1/2 mv squared plus 1/2 I omega squared, and you get 1/2 mv squared plus 1/2 mr squared, because it's a solid disk, v squared over r squared, that goes away, that's 1/4, so this has to be twice as much as that. But again, if you're interested in that, watch a different video, I do it there, you can see that there, but this is going to be twice as much, okay? So then let's draw our graph. So we're going to try to make sense. Now, when we're doing our graph, kids, okay, rather than just try to draw the whole thing, let's do points. Okay, so at the start, we're going to say purple is UG. I got nothing. Okay, well, at the start, we'll say that green is going to be KT. Okay, so we'll say I have, 1, 2, 3, 4, 5, 6. And then that means if I say, let's go with, I don't have very many colors, so we're going to go with black as KR. That means I have 3 kr at the very start. Okay. Now, when it goes up, it slows down. That means my total, hopefully everybody sees this. Actually, let's make our total bigger because it's going to be easier to see. So rather than 6 and 3, let's go with 3, 6, 9, 12, just so we have more. So I have 12 KT, let's go 10. 10 KT, and I'm going to have 5. 1, 2, 3, 4, 5 of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whew. All right. There. 10. 1, 2, 3, 4, 5. 5. Okay. All right. And that way I can show my total. Okay. And then I have no UG. Hopefully we're clear that there's not going to be any heat because it's static friction, so I don't have to worry about that. Energy get converted that. So if you take a look here, my total energy then is going to be 5 plus 10. So I can show that, and I'm going to do that with a dotted line because I don't have any colors here. So it'll be 15, 1, 2, 3, 4, 5. So my total the whole time needs to be that. That's my total. Okay. Because you know what? Conservation of energy. The total energy for my system has to stay the same. There we go. All right. Next. So again, 5 plus 10 equals my total. Okay. Well, going from here to here, I am going to lose KT. How much do we want to lose? I don't know. Let's say we lose. So we're going to call this is point A. We're going to call this point B, we'll call this point C, and we'll call this point D, okay? So when I get to point B, I have less, we're gonna say I only have 1, 2, we'll say I have 6 when I get to here, so at point B, which then means I have 3 of the KR, 1, 2, 3, but I still have to conserve my energy. So if this is 3 and this is 6, well, 3 plus 6 is 9. But remember, I need to get to 15, sorry. So then I need to also have 6 UG. So I would also put a dot right there for UG. Okay? So far, so good? Hopefully we're good. Then I'm going to get to C. Well, let's talk about C. Well, from B to C, so this is going to be my point C, and this is going to be my point D. From B to C, my KR stays the same. In fact, it stays the same to point D as well, because again, there's no outside torque. Well, so there we go. But from B to C, my UG goes up a little bit more. So maybe I went from 6 to, I don't know, 8. So we'll do that. We'll go to 8. Well, that means my KT had to go down. If my UG goes up 2 blocks, my KT has to go down 2 blocks. And then when I get to point D, I have no UG. If I have no UG, that means that I now have to have, if I have 3, I have to have 12 KT. And there we go. So I have my dots, and my dots are going to show conservation of energy. So at any of these spots, if I add this, black plus purple plus green, I have to get the dotted. Black plus green plus purple, dotted. Purple, black, green, dotted. Purple, black, green, dotted. Okay? Like that has to be the case. Okay, so hopefully that makes sense. Now we want to figure out how to connect the dots. So let's do that. Okay? We are not going to memorize. We're going to think things through. So to connect the dots, you have to look at the slope. Well, how do we find the slope? Change in y over x. Well, in this case, my y is energy, so I'm going to go change in energy over d. Change in energy over d. Well, if you look on your equation sheet, you will see change in energy is the same thing as work. So this is going to be work over d. And then hopefully we're smart enough to realize work is the parallel force times d over d, which means my slope has to be the parallel force. Pretty cool. So if we do this, all right, well, let's talk about this. For UG, well, what parallel force are we talking about that's going to cause the UG to change? In this case, it's going to be a part of the gravity, but that part of gravity is not going to change on the way up, okay? Which means that the slope for my purple has to be constant. So, sorry, that's supposed to be a line, okay? Because it has to be, the slope represents that. Going from, let's actually just do the first part first. So then if we do KR, okay, well, change in energy over work. This is, again, going to be the parallel part of the force. Well, what force is causing KR to change? Oh, that would be friction, because without friction, you're not going to have KR. So my KR, the force of friction, is going to also be constant. It's the same surface, the same normal force. So therefore, this has to be linear. So line. And then my KT happens because I'm slowing down. Why do you slow down? Well, you slow down if there's a net force. So the net force is what's causing the KT to change, and that net force doesn't change on the ramp. Okay, so that means, again, this has to be linear. Okay, so here. All right, so far so good. Next, okay, now we want to go from B to C. Okay, we already said this doesn't change, so that's because the only force acting is gravity, and gravity is not going to cause it to change its state of rotation, so that stays constant. But if I want to do the other part, so let's do the other part. Okay, in this part, it's a little weird. Okay, so it's okay. Remember, okay, it's F parallel. Okay, at the start, the only force acting is gravity. Gravity points this way. Okay, at the start, I'm moving this way. So this parallel component, okay, as I go like this, well, at the top, there is no parallel component, because, ready? It's moving this way, and my force is going this way. Well, if it's moving this way and my force is going this way, there's no parallel component. That means my slope has to go to 0. So I start with a slope, and it ends up at 0. Do we understand why? I hope we do. So that means if I was to draw this, I need to start steep and end up at 0. So like that. I need to start steep and end up at 0. Like this. And you might be like, but Lineberger, I remember in class, I did an energy versus distance, and it was a line. And I just memorized it's a line. But it's not always a line. Okay, you got to make sense out of things. Okay, in this case, because we're talking about the parallel force, force of gravity points this way, and the motion starts out like this, and then it ends up like this. So at the end, there is no parallel force. Okay, all right. So now I'm going from C to D. So if I go from C to D, and again, if you were to take at any point here, guys, black, green, purple, you have to get what we started with, the total, which was 15, okay? So going from C to D, okay, again, I am going from no parallel force to a much bigger parallel force, which means, hey, that has to get even steeper, so then I'm going to go from no parallel force to parallel force, so that's going to get steeper. No parallel force to parallel force, so my slope gets steeper, okay? And that's your graph. And you might look at that graph and go, what? But that's why you have to break it down into individual pieces, okay? Like, if you fall back on your training, you could do any problem. It's just draw your picture, make sense out of your picture, do your dots, make sense out of the slope, think it through, you can do it. Bye, kids.